Hello, today I will be giving a presentation over rheological instrumentation. This presentation will be a brief overview of the different instruments used in industry that characterize rheological properties of materials. Here is my outline. An introduction, I'll be briefly going over why we are interested in rheological properties, and then I have listed a couple different instruments used, and I'll briefly be going over what they do and how they characterize materials. Rheology is the study of deformation and the flow of material. When a stress is applied to materials, the resulting deformation is measured as strain. Classically solid materials exhibit pure elastic behavior, whereas classically liquid materials exhibit pure viscous behavior. Most materials in the world, however, are actually viscoelastic, meaning that some parts of it are elastic while other parts are viscous. So viscometers and rheometers are used to characterize these different parts to determine how much elasticity and how much viscosity each is a part of the material. And we see here at the bottom of the slide the many different types of instruments that can perform these. The first one is the Ford's cup. It is by far the simplest out of all of them. It uses simple gravity to pull a liquid through the bottom of the cup and out the hole, and this will show viscosity. The temperature is very important in this test, so temperature must be maintained, not only just the temperature of the cup, but also the temperature of the material. A Zahn cup is very similar to a Ford's cup in that you will put a liquid material in it and measure the flow of the sample out the bottom. It's primarily used in the paint industry, and they're sold in kits, where larger cups are used for high viscosity and smaller cups are used for low viscosity. The Brookfield viscometer utilizes torque to measure viscosity. So what this does is you'll put your material in a container and you'll place it underneath the machine, and attached to the machine will be a bob or spindle that will turn at a set rate. And this rate will produce drag of the material in the container, and this can measure viscosity. The temperature, the time of the test container, and the speed of the spindle can greatly affect the viscosity reading. Here we have the cone and plate and parallel plate viscometer. In this test, you place material in between a bottom plate and an upper plate or cone, and a shear stress and strain rate is calculated based on the angular displacement and the gap as the plate or cone turns. For the cone, the smaller the angle, the greater error because of the gap difference. And for larger cones, there is various shear rate readings across the gap. Parallel plates are ideal for temperature gradient tests, and they're not as sensitive to the gap setting as the cone and plate setup is. The last is the torque rheometer, which is a viscosity-related torque generated by the resistance of material to the shearing action of the plasticizing process. The analysis that utilizes this machine could include thermal sensitivity, shear sensitivity, compounding behavior, and processing behavior. It makes it ideal for process stable formalization as well as troubleshooting unwanted degradation and gel formation issues. This concludes my presentation over rheological instrumentation. These are the references I used for my paper. This is where the URL for the YouTube video will be. And these are supplemental videos to watch at your leisure. Thank you very much.